Hey everybody, the last lecture. So this is it, 7.3. This section's over what's called the ambiguous case, side-side angle. So when I was doing this, when I was making the notes for it, I wrote it as angle side-side, and then I realized the mistake I made and rewrote it. I also Googled it too. But putting the word trig after it saved me from scary things happening. All right, so side-side angle. So if you're given two sides, or an angle, and an angle, which is not between them, then we have different scenarios that can happen. So the first scenario, let me show you what we're talking about. So if I go to Desmos, I have this set, and here we can see our triangle. As far as what's given to us, let me move this around. This is given. Why did I pick the worst color possible? Let me see, blue. So this is given. This angle is given. And then this side is also given. So the only thing we don't know is the opposite side. So the only thing we don't know is the side that here is a dotted line. But let me show you the first case that can happen. So the first thing that can happen is this scenario, where because the three things are given, these two things can't move because the angle's set, so that line is set. They didn't give us the angle up here, so this angle is kind of free to rotate to make it work. But notice that it isn't enough to reach the line down there. It's too small. And so if that's the case, then you have an example of where there's no solution. Sad times. It's not long enough to reach the dotted line. Okay? So the first scenario is a no solution scenario. And again, here's a picture, kind of what I just did. The little dotted lines represent the swinging that it did. But notice it's not long enough to reach the line down here. So you can use the law of sines or the law of cosines to figure this out. I'm going to do both. So let's say we do the law of sines. So the law of sines, I know this angle, and I know the side opposite it. I know, and I'm looking for. So when you're making your graph, you really don't know in advance that it doesn't work. Here I gave you a picture, and the picture kind of tells you right away that it doesn't work, but usually you don't know. And so you would just have a triangle labeled like this, because usually we just draw generic triangles, and you would just write 36, 2, and you would try to figure out that angle. Okay, so 30 goes to 2. Here's this angle over here, this hypothetical angle that we want to find. And that's actually, this is C, this is lowercase c, so that's angle B. Okay, so sine of B, we have, so sine of B over 6 is equal to sine of 30 over 2. Okay, multiply both sides by 6. So we have sine of B equals, sine of 30 is 1/2, but just for the sake of calculators, because most of the problems you'll have to use your calculator. The angles won't be really happy like that. Times 6 divided by 2. Kind of embarrassed that I put 6 divided by 2, but anyway, 1.5. And remember that when you're dealing with sine, this is not in the range of sine. Sine must be between -1 and 1. And even if you didn't know that, and you were just kind of trudging through, if you did inverse sine of 1.5, and you try to do that in your calculator, it would give you error and tell you that it's not in the domain of the inverse function. So it's not in the range of the original, which means it's not in the domain of the inverse. So this is no solution. Let's see, DNA. And there you go. So that's how you know that it doesn't work. Can't happen. Because you get the answer that doesn't exist. So that's if you did the law of sines. And once that happens, you stop. There's no point in finding anything else about the triangle. Okay. The next one is the law of cosines. And so for the law of cosines, let me redraw this triangle. And again, you're not going to have a pretty picture that shows that it doesn't fit. So usually what you do is you just draw a triangle. And you label them A, I think the book does A, B, C. And you kind of fill in what they tell you. So they told me that A is 2, the opposite side of the angle, so that's 2. The opposite side of B is 6, and angle A is 30. And so usually that's what you're going to have on your paper. There's no signs when you're just sketching it that it doesn't work. And so if you're using the law of cosines, the law of cosines would be this side, and the angle in between. This is lowercase c, because that's angle C. This is lowercase c. And so you would write down, and here's the opposite side that it gets. So remember the law of cosines. Usually the answer it gives you is the opposite side. So 2 squared. Yeah. Let's see. That's a, yeah. Let me write out the formula first. So this is a squared. This is 2 is a. So a squared equals b squared plus c squared minus 2ab cosine of, in this case, a. So I'm just filling it in. So this is 2 squared equals b squared. That's 30. Oh, I keep on trying to do it in my head. 6 squared plus c squared minus 2 6 c times cosine of 30. Right? So we kind of work it out. We have 4 is equal to 36 plus c squared minus 12c, and then cosine of 30 is square root of 3 over 2. And I subtract 4. Basically, if you use the law of cosines, you're going to get a quadratic. If you have the side-side angle scenario, and you use the law of cosines, you're going to get a quadratic, which means you got 2 solutions. So 36 minus 4 is 32, plus c squared minus 12 over 2 is 6, 6 square root of 3c. So this is a quadratic. Let me put it in order. It's a nasty quadratic, so I'm not even going to attempt to factor that. So what we do instead is we just use the quadratic formula. C equals, remember the quadratic formula, negative b plus or minus the square root, b squared minus 4ac, all divided by 2a. So in this problem, a is equal to, it's not the same abc as over here. Just to give you a heads up. For the quadratic formula means the abc of the quadratic. So a is 1, b is negative 6 square root of 3, and c is 32. And so I plug it into my equation. Okay, so c is equal to negative b, so positive 6 square root of 3, plus or minus the square root of b squared, And you can get your calculator if you want. Oop. So b squared, if you do use your calculator though, be sure that when you're squaring something, you got to put it in parentheses. So that's 108 minus 4 a times c. So 4 times 1 times 32, all over 2a, which is just 2. And so what's 108 minus 4 times 32? Negative 20. Now this is where you stop. Because you have the square root of a negative in there, that means that we have imaginary solutions. So there's no real number that c can be. Okay. Now, yes, the law of cosines is a little more complicated than the law of sines, but in this section, we're just going over both methods, so you can be familiar with both. Yay! So that's scenario 1. So the summary, if the sides end up imaginary, or if the if the sine or cosine, I forgot to put in the blank here, of an angle is more than 1 or less than negative 1, then there's no solution. So in this section, they make it seem like there's a lot of rules, but honestly, it's just doing the math. If you use the law of sines and cosines correctly, then it'll tell you no solution. You will get an error when you do that. When you do the law of cosines, you will get an error when you type that in your calculator. It'll say error, no solution, or imaginary solution. For instance, if I do plus square root of negative 20 over 2, forgot to put the parentheses in the very front. Doesn't matter because it's going to give me an error. It says non-real answer. So just do the math, and the math, when you type it in your calculator, it'll go, and you know you don't have an answer. All right, so let's go to the next page. You have scenario 2. Find angle B in triangle ABC if A equals 4, B equals 5, and A equals 53.13. So this is a case where we're going to have just one solution. Okay, so let's label this triangle. A is 53.13. The side across from it would be 4. The side across from B would be 5. And you can look at it and know what's going to happen. This isn't to scale, but notice you got blank 4, 5. So we can already tell that this side is going to be 3. It's a 3, 4, 5 triangle. 3, 4, 5 triangles are right triangles. But we're pretending that we don't know that. So we're using the law of sines, law of cosines. So using the law of sines, you would try to figure out angle B. And you do exactly what you did on the other side. Sine of B over 5 equals sine of 53.13. Whoop. I keep on putting 15. I don't know why I do that. Over 4. Remember the law of sines. You pick the side with its opposite side. Okay, multiply both sides by 5. So sine of B is equal to, get your calculator, and you can type that in. Sine of 53.15. I keep on doing 15. 13 times 5 over 4. Okay, so I rounded when I made that angle. But notice it's 0.9999999. That's pretty much 1. So sine B equals 1. Okay. Now notice this is a case that only has one solution. I mean, yeah, you can do the inverse sine. Inverse sine of 1 and get 90. But this only has one answer, because if you were to draw the grid here, where this is 0 degrees, this is 180 degrees, the only time that sine is 1 is right there. That's it. There's only one solution. There's not the 270 because that's equal to negative 1. Okay, there's not two quadrants because it's right on the axis. So that you don't have two quadrant solutions. So you do the math and you only get one solution. So the inverse sine, so B equals the inverse sine of 1, B equals 90 degrees. There you go. Good stuff. Yay! Again, you could do the same thing with the law of cosines. I don't want to use the law of cosines. So 53.13, Phillips character, guess, 4. So that's what you're given. If you're doing the law of cosines, you have to use the angle between two sides. And the answer ends up being the angle opposite. So since this is the only angle I know, the two sides have to be 5 and C. You can call it X, whatever. But anyway, so we're going to use the law of cosines. So it says that the other side squared, the side opposite the angle squared, is equal to the other two sides squared, so 5 squared plus C squared, minus 2, those two sides again, 5 times C times cosine of the angle between the sides, 53.13. Okay, I don't know why I put that in blue, but let's go with it. So 16 equals 25 plus C squared. On your calculator, I'm going to type in 2 times 5 times cosine of 53.15. Why do I keep saying 15? Oh my god. And notice that that's pretty much 6. So minus 6C, wrong color. And I can subtract the 16. So this gives me 0 is equal to C squared minus 6C, and then 25 minus 16 is plus 9. So notice that if you do the math, a quadratic always has two answers. But it just turns out that the answers here are the same. X minus 3, X minus 3. So X minus 3 equals 0. I know this is overkill, but X equals 3, X equals 3. So yes, the quadratic formula always gives you two solutions, but sometimes those two solutions are identical. In the previous example, the two solutions were imaginary. Okay? And then in the next scenario, there's going to be two different solutions. And then the next scenario after that, two solutions, but one's positive, one's negative. All right. Anyway, so notice that, well, technically we're not done here because the question said find angle B. So we found out that C was 3. So we know it's a 3, 4, 5 triangle. And so from there, you can do what you wanted to do, whatever you want to do. You can use law of sines or law of cosines. So I'm just going to use the law of sines. And it's the same, well, actually, it's the same thing as over here. But I'll use the new information. So I just don't want to use the law of cosines again. You know what? I'll use the law of cosines again. I'll stick with it. I'll stick with it. If you're taking notes, I'm sorry for your eraser. Okay. So we got 3, 4, 5, definitely not to scale. We want to find this angle. And since we're using the law of cosines, now I can go ahead and figure it out. Okay, so remember the cosine version of it, or the angle version of it, was cosine of, this is B, is equal to the other two sides, so 3 squared plus 4 squared minus 5 squared, all over 2, 3, 4. And so we just do the inverse cosine of that. So we get our calculator, and let's do the inverse cosine of parentheses 9 plus 16. Oh, God. You know what? I'm just going to figure out what that number is first. So 9 plus 16 minus 25 is 0. And 0 over that is 0. So, well, that should make, okay, anyway. So, B equals the inverse cosine of 0. And in this case, that's 90 degrees. Okay? Mm-hmm. Now, well, technically there's two answers. 90, when is the x value equal to 0? It happens at 90 degrees and at 270 degrees. But I ignore 270 because the angles in a triangle have to add up to 180. So 270 is already too much. So I just stuck with the 90 degrees. Anyway, so the law of cosines is a lot longer. I had to do it twice in order to get angle B. But I get the same answer. So the summary here is if the side opposite the angle is equal to the height of the triangle. Okay, so remember the height of the triangle is the distance from any point. You know what? I'm not going to go over it. But the height of the triangle is actually the length here. So then there will only be one solution. So the height of a triangle is the distance from the angle to, and then the line has to make a 90-degree angle with the triangle. So if you have a generic triangle, the height is that. Cool. In this case, though, it happens to be, if the other side equals it, then you have a 90-degree triangle. All right. So if I go to Desmos and show this example, this is if the given side, I think it was 1.4. Yeah. So notice that it doesn't hit, and then bam, it hits right there. And then it doesn't hit anymore. So that's the one solution. Anyway. But again, I want you to notice that doing the math, there was only one answer. So no matter how you do it, I did the math with law of sines, there was literally only one answer. I did the math with the law of cosines, and there were two solutions, but they were the same. So there's just one answer. So no matter how you do it, it'll tell you, doing the math will tell you if there's only one solution. The next scenario. So the next scenario is, you guessed it, two solutions. Okay. So going back to Desmos, this is the case where the angle, so I can have one answer here, or I can have another answer over here. There's two different triangles that can be created with that length. All right, so let's do it with the law of sines. Now this problem says find the missing parts. So after we figure out the angle, we're going to do more stuff after it. And it turns out that here this is B. I'll explain why in a bit. So this is 40 degrees. This is 54. B is 62. And they just want me to solve the triangle. So I'm going to use the law of sines. I have to find angle B first because I don't know anything about C. I don't know C, and I don't know the side opposite of C. So, law of sines, sine B over 62 equals sine of 40 over 54. 54, yeah. So multiply 62 to both sides. So I have sine of 40 times 62 over 54. And we just find that's going to be an ugly number, so I'm just going to find the inverse sine of that. So calculator on. So inverse sine of sine 40, close it, times 62 divided by 54. And I get 47.6. Right? Good stuffs. So well, you may be thinking, well, Gilbert, that's only one solution. How do I know that there's two solutions? It's because remember that this is only a reference angle. It's always a reference angle. So there's two places where you can have 47.6. Sine is positive here and here. And so you can have 47.6 this way, or you can have 47.6 this way. Now to get the other angle, so the other angle would be 180 minus 47.6, 132.4. Right? And so that means that we have two triangles to solve. I put a kitty in the corner. Kitty. So the first one, let's start with the 47.6. Triangle with B equal to 47.6. So in that case, this triangle is going to look like this. It's meh, meh, meh. So 47.6, 40. Well, since I know, I know this side and I know this side. So now I pretty much know everything. I can figure out the missing side, the missing angle, because 180 minus all that. 180 minus 47.6 minus 40, 92.4. So I know that. All I'm missing now is this side down here. So since I'm using the law of sines, I'm going to stick to the law of sines. So I can say this is C. Oh, I'm looking for a side, so I'm going to put that on top. C over sine of 92.4 is equal to, and I can choose whichever one I want I'm just going to pick the A. So 54 over sine of 40. So multiply both sides. So C is equal to, get your calculator and type it in. 54 times sine of 92.4 divided by sine of 40. And I get 83.9. Again, like I've always said in previous lectures, the homework will tell you how much to round to. So sometimes it'll say round to the nearest unit. Sometimes it'll say round to 1 or 2 decimal places. So C is 83.9. So now I have everything. The triangle is now fully solved. Yeah. But now let's go ahead and do the other triangle. I need to give myself some room. No, I left it out. So tiny. Got it. I got it. I got it. There we go. All right. I'm trying to make it look nice, so trying to be organized. All right. So that's the triangle with 47.6. The other triangle was 132.4. And so this triangle looks a bit different. This triangle looks more like that, where we know this is 62. I know this is 54. I know this is 40. Okay, and I know that this is 132.4. So right off the bat, I can figure out the missing angle. 180 minus 40 minus 132.4. 7.6. So this missing angle is 7.6. So all the angles are solved for. Just like before, I'm missing this side. Oh, and by the way, for here, in the textbook, they use A, B, C, and when they solve the other triangle, they say A, B prime, C. So for the two angles, they call one B and they call the other one B prime. So using the law of sines again, I'm going to do this angle is the opposite angle. Use that. So C over 7.6. Remember, this is the lowercase c. So lowercase c. C over sine of 7.6 is equal to 54 over sine of 40. Multiply both sides by sine of 7.6. So what do we get? 54 times sine of 7.6 divided by sine of 40. I get 11.1. There's the missing sign. Okay, so that would be C. Since there's two B's, that means there's two C's. So this would be C and this would be C prime. I used the wrong color. You know that feeling when it's the end of the semester and you're just done? Like, I'm done. That's kind of like how I feel right now. Teachers get it too. All right. Yay. So that's two solutions with the law of sines. Now I'm going to do the same thing, but this time with the law of cosines. Notice it's still scenario 3. I don't want to do scenario 3 anymore. So if we do the same exact thing, but with the law of cosines, rather than finding angle B first, we instead find this guy first. But we have to pretend that it's sandwiched between, because we know angle A. So let's do it. We fill in the info. This is 54. This is 62. A is 40 degrees. So if we do the law of cosines, all cosine says 54 squared is equal to the two other sides squared, 62 squared, plus c squared, minus 262 times c times cosine of the angle, so cosine of 40 degrees. Now we just got to go ahead and solve it and see what we get. Now the numbers here are going to be pretty big. 54 squared is 2916. 62 squared, 3844, plus c squared, and then 2 times 62 times cosine of 40. So that's really close to, that actually rounds up to 95. So I'm just going to say 95c. I subtract minus 2916. $928. So 0 equals c squared minus 95c plus 928. Now, I'm not going to attempt to factor that. I'm just going to use the quadratic formula. So c is equal to negative b. So my temporary, again, not the a, b, and c from here. I'll put quadratic formula variables. So a is equal to 1, b negative 95, and c 928. All right. So c is equal to negative b, so 95, plus or minus the square root of b squared. When you're doing b squared, guys, parentheses negative 95 squared. Or don't even type in the negative. When you square it, you know it's going to be positive. So 9025 minus 4, a times c. A is just 1, so 4 times 928. And then the whole thing divided by 2. So I'm going to figure out what that square root is. Square root of 9025 minus 4 times 928. 72.9. So 95 plus or minus 72.9 over 2. And whenever I type this in, I'm going to get two answers. 95 plus 72.9 over 2. 83.95. Or 95 minus 72.9 divided by 2. And 11.05. Notice that these are the same, pretty much the same thing. I guess I'll round it up. 83.4 11.1. And so I get two solutions, and they're the same answers that I got when I was using the law of cosines. Sorry, law of sines. See? That was 83.9. This one is 83.4. So there's just a little bit of rounding error. 11.1, that answer ended up being the same, though. The larger the numbers are, the more chance you have for some little rounding errors here and there. Anyway, so let's do it. Now that we know the two sides, let's use the law of cosines to finish it off. Shrinky-dink. So we have the triangle that's 83.4. And notice that we know all three sides now. I know this is 83.4, this is 54, this is 62, and I already know this angle is 40. All I have to do is use the law of cosines to figure out the missing angle, and then 180 minus that. So using the law of cosines, let's go ahead and find this one. I know that cosine, this is angle A, angle B, angle C. Cosine of B is equal to the two sides that are sandwiching it. Here's the opposite side. So the two sides that are sandwiching it squared minus the opposite side squared, all divided by 2 times 83.4 times 54. So B equals the inverse cosine of that stuff once I figure it out. So 83.4 squared plus 54 squared minus 62 squared divided by 2 times, I had to put them in parentheses. 2 times 83.5, 83.4 times 54. Okay, and so let's do the inverse cosine of that. And I get 47.9, so pretty much I get 48. Again, so the answers are really close to what I got before. So before it was 47.6, here I got 48. It's all rounding. Like if we didn't round at all, the answers would always be the same. But the reason it's a little bit off is because notice I used a rounded number here. 83.4 was a rounded number. 83.4 is a rounded number, so that's why it's off. When we did the law of sines, the 47.6, the angles were the rounded numbers. And so if the problem tells you to do law of sines, use the law of sines. If it tells you to do law of cosines, do law of cosines, because you don't want to be off by a little bit and then get it wrong and then throw a big hissy fit. Right? So if that's 48, then the other angle must be 180 minus 40 minus 48. You get 92. All right, so that's that one. Now the other triangle is where it's equal to 11.1. Rounding is everyone's downfall. So 11.1, 54, 62. This is 40. And so this is B prime. This is C prime. This is still C. This is still A. All right, so let's figure it out. Same thing. So it's exactly the same as before. Cosine of B. I'll use a different color. Too much black. Equals. So I'm trying to find cosine B. So those are the sides again. 11.1 squared plus 54 squared minus 62 squared over 2, 11.1, 54. So cosine of B, B equals inverse cosine of all that junk. It's not junk, it's fun. Yeah. Yeah. So I divide that by 2 times 11.1 times 54, and I get negative 0.6713 inverse cosine of that. So 132 point, rounding to one decimal place, so 132.2. And when we did it with the law of sines, I get it was 132.4. So 2/10 off because of rounding. Anyway, 180 minus 40 minus 132.2, 7.8. So there you go. I solved the triangle.
I don't like the law of cosine.
So the summary here, if the side opposite the angle is greater than the height but smaller than the largest side, there will be two solutions. So what do I mean by that? Well, if we go back to Desmos, so notice that my angle, the line isn't longer than the other side. So it's not longer than it. Okay? But it's bigger than the height. So if it's in that sweet spot, you have two solutions. If you go more than that, though, no, I changed it. My life is a lie. There we go. So if you do it with this one, notice that there's only one possible answer because it's bigger than the line, and that's the last scenario. Okay. Let me do 2 pi. Just hit play. So this is the last case. Okay. Notice in this case, there's only one real answer. Because I want a triangle with the given angle, and it's too big. I can't count this one because that's not the given angle. That's not the triangle. The only triangle that can be created is that one. Oh, I missed. All right. Anyway, let's go to the last page. So scenario 4 is again one solution. So find the missing part. So this is if A is greater than B. Find the missing parts in triangle ABC where A equals 314, B equals 205, angle A is 35.4. So I'm just going to do the law of sines, get my answer. Do the law of cosines, get my answer. So the law of sines, again, just like all the others, sine of b over 205 is equal to sine of a over 314. So sine of 35.4 over 314. So b is going to be the inverse sine of that. So get my calculator. So inverse sine, you know what, I'll just type in sine 35.4 times 205 divided by 314, and then the inverse sine of that. Second answer, 22.2. Okay, 22.2 degrees though can happen in two quadrants. 22.2 can be here. 22.2 can be here. So if I do 180 minus 22.2, I get 157.8. So the two solutions you get are not only 22.2, but also 157.8. Okay? So why is there only one solution? Well, think about it. If one angle was 40, so 22.2, plus 35.4 plus the other angle has to equal 180. So notice that here, 157.8 plus 35.4, it's already a 193.2. And I haven't even found the missing angle yet. Okay? So it can't be 157.8 because 157.8 plus the given angle is more than 180. And so we cross it out. And so really I only have one solution, 22.2. And so this is the 22.2. So 180 minus 22.2 minus 35.4, 122.4. That's this angle. Now all I'm missing is this side. So let's go ahead and use the law of sines because we're in that mindset. I wrote my question mark. How dare I? All right. Okay, so to find the missing side, it's going to be c over sine of 122.4 is equal to 314 over sine of 35.4. Oh my God, who's blowing up my phone? And so when you type that in, we get the missing side is sine of 122.4 times 314 divided by sine of 35.4. So 457.7. There you go. Triangle has been filled in. Now to close this off, we're going to do it yet again for the law of cosines, which is going to produce a quadratic. So redrawing my triangle. I know this is 35.4. Here's 314. Here's 205. And that's all they give us. So the law of cosines, again, you have to use those two sides to figure out this side, but I already know that side. So 314 squared is equal to 205 squared, that's side C, plus C squared, minus 2 times 205 times C times cosine of 35.4. Then we end up with a quadratic. I'm going to kind of do stuff in my calculator. So 205 squared, I'm going to end up subtracting the 314 squared. Might as well do that now. So 0 equals C squared, and then here 2 times 205 times cosine of 35.4. It's about, I'm just going to say 334. So C squared minus 334 C plus, minus 56,571. Nasty. But we use the quadratic formula. Stay diligent. So 334 plus or minus the square root. Just going to go ahead and type all that in my calculator. The square root of b squared. The negative will cancel out, making positive anyway. Minus 4 times ac, negative 56571. So 337,840 over 2. So the square root of 337,840 is 581 point. So I'm just going to say 581. These numbers are huge. 334 plus or minus 581 over 2 plus 581 over 2. And that's 457.5. Here, 457.7. So very close. And the other one is 334. Let me clear the calculator. 334 minus 581 divided by 2. Negative 123.5. So notice even the law of cosines tells us that we only have one solution. The only solution I have has to be the positive answer, which means this negative solution doesn't make sense. So we have one answer, and if I know this is 457.5, I can figure out the missing angles. Okay, so to find the missing angle, let's say we have cosine of b is equal to, now I'm looking at this angle. So these are the two sides, and here's the opposite side. So cosine of b is equal to 314 squared plus 457.5 squared minus 205 squared, all divided by 2 times 457.5 times 314. And so b is going to be equal to the inverse cosine of that. divided by parentheses 2 times 457.5 times 314. So that, and so b is equal to the inverse cosine of that stuff. So notice 22.3, but it's still very extremely close. And so if this is 22.3, then you have 180 minus 35.4 minus 22.3. $122.3. There you go. Now the triangle is solved. Okay. Yay. Yeah, I know it was a lot of repetitive work in this section, but I really wanted to show the law of cosines being done a lot. Because, yeah. All right. So the summary: if the side opposite the angle is larger than the other side, then there will be one solution. Now, I don't like memorizing the different scenarios. Notice in every single scenario, all I did was I did the math. The math tells you how many answers there are. If both answers are positive, you got 2 answers. If both answers are negative, then you got no answers. If answer is positive, one answer is negative, you only got 1 answer. So the summary is just do the math. Answers that are imaginary, negative, or make the sum of angles more than 180 need to be thrown out. That's it. Okay. This homework, I think, only has 8 problems. So let me know if you have any questions on it. And it's last homework. Your exam's going to be Friday, and the next week we're going to have our final exam. All right. Y'all have a good one. Be safe.